Okay guys, this is the first video I'm going to make on dealing with graphing, data, looking at charts, tables, that sort of thing. Because really this is a skill that isn't taught directly a whole lot in high school science classes, but it's one of the most important skills that you can come away from a science class with, I think, because this is not only important in science classes, but it's going to be important your entire life. Being able to look at data and look at a graph and make a graph is really going to help you out in innumerable aspects as you go through life. Not to mention, obviously in your science class it will help you, but it will also help you in all of your other academic courses. There's lots of graphs in social studies and economics and math and that sort of thing. So looking at data and graphing and looking at charts and tables is a super important skill. Now we'll start with the three kind of basic types of graphs. Number one is the bar graph, and this graph is used for counted data. It uses bars to indicate the number of responses per item. Now these can be flipped horizontally or vertically. Right now we call this vertically because you can see the bars, they're going up and down, they're vertical. You've probably seen some that go horizontal, sideways. This is the more common way to look at it probably. Now we can see bar graphs are used when you have different categories and you count the number of things in each category. So for our example here, I used favorite activities for MGLVA high school students. Now this is fake data. I've made up this data, but this could be something that might happen with MGLVA high school students. And so this would be like you gave a survey to all the high school students with these 1, 2, 3, 4, 5 choices, and then you just counted the number of people that chose each activity. So we can see visiting with friends, that was 175 students' favorite activity, right? So it's just having categories, you're counting data in a specific category. That's when you use bar graphs. And then we just take the data from the table and you can see visit with friends. Here's the bar for visit with friends and it goes up. On the y-axis we can see his number of people to, oh yep, 175 people. Second type of graph that maybe is the most common that you'll see in your classes is a line graph. So line graphs graph changes in data. Example is a change in temperature over time, and they do this by plotting points on a graph and connecting the points. Now in later lessons we'll go over times you don't necessarily connect all the points. Sometimes you use a trend line, but we'll talk about that in a later video here. So remember that a line graph graphs changes in data, and a very common thing is they'll graph changes in data over time. So generally if you see time, you're probably going to make a line graph because things will change, a reaction will change, or something will change as the time goes on. Temperature is a great example, right? You wake up in the morning, it's generally pretty chilly, and then that temperature will go up during the day and then it will kind of fall back down at night. So the temperature changes over time, and a line graph lets us see that change. So the example here we'd have, these would be like different days, the high temperatures for different days in New York City. And this is probably during, that's probably during maybe the spring. It looks like it's warming up quite a bit. So day one would be a high temperature would be 45 degrees. So we have day on the x-axis, degrees in Fahrenheit on the y-axis, and yep, there's 43 degrees on day one. Day 2, 53 degrees. Day 3, down to 50, and so on for all 6 days. Last one we'll look at is pie chart. Now, pie charts are good when we want to look at percentage of a data. And it's just like it sounds. It's a circle divided into pie pieces. So if you have something where you want to look at the percentage of something, then you'll use a pie chart. And a good example is how people spend their days, right? Because people have to use all 24 hours. They have to use 100% of 24 hours. You can't just cut out an hour, right? So a pie chart works really well because you have to use 100% of the day. And we can see here sleeping would be 25% of the day, school 25%, job 17, and so on. And this is what this student would spend doing for an entire 24-hour period based on percentage. Now, a couple things that all graphs have in common, and this is really, really important that all your graphs have these things. They all need a title. If you don't have a title, no one knows what your graph is about, right? If this graph didn't have a title, I would be like, oh, I don't really know what this is. Sleeping 25%, I don't know what that means. Right? If this line graph didn't have a title, these would just be random numbers. They could be anything. These could be maybe how high let my vertical jump in inches over number of weeks, right? If we don't have a title, we don't know what the data is telling us. Axes labels, they define the graphed data. And examples are time, number, temperature, etc. So you have to graph, or you have to label both the y, which is the vertical, and the x axes. So in this example, the x-axis is day, and the y-axis is degrees in Fahrenheit. And it's important to be specific. If I just said degrees, I don't know if that's in Fahrenheit, Kelvin, or Celsius. So you need to be specific and detailed when you're labeling your axes. Now that goes for line graphs and bar graphs, right? With pie charts, there's not necessarily axes, but you need to make sure you label all your percentages, right? If you don't label this 25%, I have no idea what you spent 25% of your time doing. Uniform tick marks. So graphs must be uniformly incremented, meaning every line or every square would be the same. And it could be 1, it could be 5, it could be 50, but they need to be the same. And again, this goes for bar charts or bar graphs and line graphs. Notice on the x-axis here with days, each line down here is equal to 1 day. We don't have we don't have this being equal to 1 day, and then maybe we jump up. Maybe this would be like 5 days now, and then 6 days, and then 10 days. No, each line is equal to 1 day. Same thing going up the y-axis, right? Each dark line is equal to 20 degrees. We can't start at 0 and then go to 20 and then go to 100 and then go to 120. No, we can't do that. That wouldn't make sense. Our line wouldn't look right. So they have to be the same increment. And then graphs do not have to start at point 0, 0 unless you have a data point at 0, 0. And again, we can look at our line graph, right? We don't start at day 0. We don't have any data for day 0, so we don't need to start at day 0. So you can kind of start where your data starts. Otherwise, you're just going to have a really large blank space on your graph. And we just care about the data. So you need to make sure that you start your scales where your data starts. On the flip side, when you're looking at graphs, you need to make sure that you're looking at the scales, because you cannot assume that graphs start at 0 on the y-axis and 0 on the x-axis. So whenever you're looking at questions or problems or any graph, make sure you're looking at where that graph starts and make sure you're looking at the scale. And this is just an example here. We point out some of the important things that we've just talked about, right? The title, the axes, the uniform tick marks, or that's also called the scale. And then it doesn't have to start at 0, 0. So here's our descriptive title, right? It's telling us what this data is all about. Here's our axes labels. Grids are uniformly incremented. We just talked about that. The day is going up by 1 day for each line. Temperature is going up by 20 degrees for each dark line. And then we just said this graph, yep, it does not start at 0, 0. Starts at 1, 0. As the first data is day 1, we don't have any data for day 0, and so that's how we start it. Now, an important point, we could have started the graph at 140, as that's the data range. So notice this blank space right here. If we look at the 40 degrees and under, that's all blank space. We don't really need that, right? We could kind of zoom in, if you will, on our data, and we could start our y-axis, we could start it at 40, and we could cut out all this blank white space. So that's why it's really important to always check and make sure you know where your graph is starting, what that first point is, and if you're reading a graph, make sure you look down here so you know what data you're looking at. And that's going to be all for this lesson. We'll keep going with the next one.